Hello everyone. So today's topic is on biotransformation of xenobiotics. It's a very small topic, an important short note from university point of view in paper 2. So we'll just understand the basics of it. Okay. Now, the title itself, if you take, we have two new terminologies. What are the terminologies? One is about something called xenobiotics. Another, we have a good term called as biotransformation. So now the first step for this topic is to understand what is the meaning of xenobiotics and what is the process. So it is ending with some ION, so it is obviously going to be some process that takes place in our body. So what is this process? Why this process is operating in our body? See, every day we consume some food or we take some tablets. Like if you have your parents who are known to be diabetic or who are on hypolipidemic drugs or who are on thyroid drugs, so and even you, okay, so since you people are in front of screen for more than 8 hours per day, you tend to have some headache, so you go and take some paracetamol. So everybody on a routine basis, we take some drugs. Of course we take food, and in food, no, we add these pickles, or if it is chapati, we tend to take it with jam. Okay, so every food you take, we have something called as preservative, right? We have something called as coloring agent. You take drugs, it is a chemical. So in our body, on a daily basis, we are introducing our body to some substances. And not all substances are non-toxic, right? So there are going to be some substances that are going to be toxic. And even our body is synthesizing some substances that can either be non-toxic or toxic. So all these substances that are going to be taken by us or it is produced by the body, which are known to be toxic, is called as a xenobiotic. Xenobiotic na basic enna, it's a toxic substance. In the toxic substance, either you are going to consume or you are going to introduce to your body by means of diet, or your body itself is going to synthesize some toxic substances. So it is generally called as a xenobiotic. Now, are toxic substances beneficial for our body? No. And the toxic substances, if they are going to be present in our body, it is going to cause some serious manifestations and it is going to pose a serious threat for our body. So our body is trying to eliminate these toxic substances as much as possible. If it is not able to do, then that substance is going to accumulate in our body and we call it as toxicity. So in general, are we seeing toxicity? No, because there is some inherited mechanism in our body that is removing all the toxic substances. So the xenobiotics are the substances what I am referring to as the toxic substances, and biotransformation is the process by which all these toxic substances are rendered or it is being converted to non-toxic and being eliminated. So in the transformation, transformation is nothing but no changing in one form to the other, right? So it is being transformed to one form to other. Now what we are trying to understand by that is simply that there is no change of one form to other. So this is what we are going to see. So how the body is converting all the toxic substances, etc. Okay. So I'll be just highlighting some definitions, some important points that you must include in the exams. So have this as a base and have a reading. It will be very helpful for you. So first, let us have some quick points on xenobiotics. So compounds which are accidentally ingested. Okay, so you work on a field, okay, suddenly you tend to take some fruit without the knowledge, and that can be a toxic substance, or drugs, as I said, or a metabolite of a bacterial metabolism in the body. So compounds which are either ingested in form of a food or something, or you take it as drugs, or it is a metabolite of a bacterial metabolism, or any substance produced in our body, are collectively called as xenobiotics. So these three are the keywords for definition: accidentally ingested, drugs, or metabolites of the bacterial metabolism. So these three classes of compounds can come under xenobiotics. Now, so we have seen there is some toxic substance in our body. So we should go for biotransformation. So as I always said, I mean in the beginning I have told you, transformation means converting of one form to the other form. So if you take, this is what is this flow chart or representation that I have put here is the basic understanding of this biotransformation. So substance 1 is a xenobiotic, which can be a drug or a substance that you have accidentally ingested like a preservative or something, or it is a metabolite of a bacterial metabolism. Now these metabolites is going to be metabolized by our body and it is going to be rendered non-toxic. So in the பக்கம் இருக்கிறது எல்லாமே என்ன, they are the toxic substances. So the conversion, the chemical reaction that is going to convert these toxic substances to another substance which is going to be non-toxic, and this non-toxic substance, this substance 2, is going to be excreted. So this is called as biotransformation. So to go on to the exact definition, the process whereby a substance is changed from one chemical to another by a chemical reaction where it is taking place within the body. So in the xenobiotic and our toxic substance, you can take either it can be an exogenous, that is outside the body, or the endogenous. But in the biotransformation is an endogenous reaction, meaning it takes place within the body alone. So we have seen the introduction to our title, biotransformation என்ன, எங்க நடக்குது, யாருக்கு நடக்குது, and what is that xenobiotics we have seen. So these are the basic information. So what you should carry over now is xenobiotic ன்றது ஒரு toxic substance, and அந்த toxic substance வந்து non toxic ஆக்கிறதுக்கு we have a chemical reaction that is taking place, that is biotransformation. Okay, so these are some basic terminologies. Now, the first short note that they can ask you is about a group of enzymes called as cytochrome P450. Now, I have introduced you to some reaction. Okay, nama body there is going to be some chemical reaction that is going to take place, which is going to convert the toxic substance to the non-toxic substances. So any chemical reaction, the next terminology that we will think about is the enzyme. Which enzyme is present, how it is helping the chemical reaction to take place and all that. So we have a specialized group of enzymes called as cytochrome P450. Okay, why we have this 450 is because it refers to the wavelength of light. Okay, so this enzyme is going to absorb 450 nanometer of wavelength of light, and it is going to be activating some chemical reactions. We have this 450. Okay, so the first point, it is a monooxygenase enzyme, heme containing enzymes. Okay, so it is going to have cofactor as heme, and where it is present in the reticuloendothelial cells of the liver. So it is a monooxygenase heme containing enzymes that are located in the reticuloendothelial cells of the liver. Very important point is the coenzyme. Okay, so we are going to have this NADPH that is going to act as the coenzyme for all the enzymes. Okay, so first point, it is a monooxygenase heme containing enzyme that is located in the reticuloendothelial cells of the liver, and its coenzyme is going to be NADPH. So hydrolysis of this enzyme is going to render the enzyme active, and then the chemical reaction is going to take place. It contains about 150 isoenzymes. Okay, so we are going to have so many enzymes that is going to fall under the cytochrome groups. Okay, so we have around 150 isoenzymes. I hope you all know what is an isoenzyme. Like you have studied already, like LDH has 5 isoenzymes, and then creatinine kinase you would have studied, right? So isoenzyme or group kulle you're going to have different subtypes or subfamilies, right? Now, classification. So there are about 150 isoenzymes. So how we are going to classify is this CYP, that is cytochrome P, this abbreviation is going to be common to all the 150 isoenzymes. Like we will have CYP1A1, CYP2E1, CYP2C9. We are going to have so many enzymes, and all these enzymes is going to contain a common abbreviation called as CYP. Then how these enzymes are classified into different groups is based on the family and the subfamily to which it belongs. Okay, so if you take family is denoted by the number. Okay, and subfamily is denoted by the alphabet like A, B or C something. And after this alphabet, you are going to have one number that indicates the number or the position of the enzyme in that subfamily. Nalla purinjikonga, any enzyme you take, the common thing that we are going to have is CYP. After which we are going to have the family. Okay, so first family or second family or third family, we have some families. And we are going to have subfamilies in this family like A, B, C, etc. So suppose I give you like CYP2 abdina, we are going to choose an enzyme from the second family. So second family, what is the subfamily? I am going to take A. And this enzyme 9 abdina potana, in the subfamily A, I am choosing the ninth enzyme. Okay, we'll just understand. Okay, it's like Chennai or Bangalore. Okay, you choose one area like Chennai la we will take Velachery, or Tambaram we will take. Anga I am choosing one family. That okay, so that is no subfamily A, and under subfamily I am choosing you as one person. Okay, so this is the classification. So CYP common abbreviation followed by family, followed by subfamily, and subfamily key next number is going to denote the position of the enzyme in that family. Okay, so this I just want you guys to include if this question is asked. That is why I gave you such an explanation. So the next point is about some important things. See, I told you we are going to take some important drugs also day to day life. Like some people they take diabetic drugs, some people they take hypolipidemic drugs, some people they take a paracetamol for a day, or some people are on many medications, right? So every drug that you take, it is ultimately going to be metabolized by the cytochrome P450 complex, and it is going to be excreted in the urine. So there are some drug interactions that we need to avoid. Okay, so we will be learning this in detail in pharmacology in the second year. You guys will be learning, but I just want you guys to include these examples in the exam. First example, if you take, I have chosen an enzyme called CYP2C9, which means enzyme belonging to the second family and subfamily of C, and I have chosen the ninth enzyme in the subfamily C. Okay, so cytochrome P2C9 அப்படின்ற ஒரு enzyme. And here I have mentioned two drug names, warfarin and the phenobarbital. If you take this drug, warfarin, an excellent drug, it is used as an anticoagulant. Okay, so people who know, some people are on anticoagulants. Okay, so this warfarin is going to be metabolized by the CYP2C9. Nalla kada purinjikonga. I am on warfarin therapy. It is an anticoagulant. Okay, so if I am taking this drug is going to be metabolized by CYP2C9. Okay, so metabolization and the drug is going to be distributed in necessary tissues, and it is going to be metabolized and excreted. Okay, so normal amounts it is going to be given to my tissues, and also it is going to be excreted. Now, this cross indicates it is contraindicated, or this has to be avoided when you give phenobarbital. So phenobarbital, it's a drug that belongs to a class of barbiturates. Okay, so we use it as a sedative hypnotics. Okay, sometimes even in epilepsy we will be using phenobarbital in the later stages. Okay, status epilepticus no condition we will be using phenobarbital. Okay, so basic thing is, if you are giving phenobarbital, this phenobarbital will enhance the activity of CYP2C9. நல்ல ஸ்டோரி புரிஞ்சுக்கோங்க. வார்ஃபாரின் அப்படின்னு ஒரு ட்ரக் கொடுக்குறீங்கன்னா, this drug is going to be metabolized by a cytochrome enzyme called CYP2C9. Now, phenobarbital அப்படின்னு ஒரு drug which is a barbiturate, it is going to enhance the activity of CYP2C9. It is going to induce the activity, or it is going to increase the activity of CYP2C9. So இப்போ ஒரு பேஷண்ட்டுக்கு I am giving warfarin as well as phenobarbital. Now what is going to happen? This phenobarbital is having an inducible activity on this enzyme. So the CYP2CN enzyme or activity will be over exaggerated or very increased so much now. So the metabolism of warfarin is also going to be increased to greater extent. So the metabolization of warfarin will be more. So the drug is not going to reach properly to the required tissue. So when you give warfarin along with phenobarbital, in the activity of warfarin is going to be suppressed because phenobarbital increases the CYP2C9 levels. Okay, so another number textbook has given a beautiful line. Cytochrome P450 is an inducible enzyme, which means you can regulate the activity, or you can initiate an activity of an enzyme by some factors. So in the CYP2 enzyme, phenobarbital you will be able to enhance this enzyme. Henceforth, if you're going to give warfarin along with this phenobarbital, this enzyme is going to completely metabolize the drug. Hence, it might not be available for the concerned activity. Okay, I hope you are clear. Any doubts you can post in the comment section. Next, ethanol. Okay, so ethanol, if you take, it is by an enzyme called CYP2E1. Okay, so again, if you take this CYP2E1 enzyme is responsible for activating the carcinogens. Okay, and if you take this, ethanol is the factor that can induce the activity of enzyme. So you can remember like E for E. Okay, so in general, this enzyme is meant for activation of carcinogen. But if this enzyme expression is not that much, our body will try to suppress this carcinogenic activity. But you consume more amount of alcohol, what is going to happen? This enzyme is going to be activated so much. Then there is going to be more amount of activation of carcinogen. Then it can lead to cancer. Okay, so ethanol is going to induce CYP2E1, and thus it is going to increase the carcinogenic action. And if you take CYP1A1, it is going to mainly enhance the activity of aromatic hydrocarbon hydroxylase. Okay, so we'll study that. It is just going to hydrolyze the aromatic hydrocarbons. That's it. CYP1A1. So if somebody asks you, give some examples stating or concerning about cytochrome P450 as inducible enzymes abdina, you can give these two examples: interaction between warfarin and phenobarbital and ethanol. Okay, so how this is going to induce the enzyme activity and what is the net effect of that induction of the enzyme abdina, you can give. Okay, and polymorphism by CYP2A6. You would have heard this many people saying, Tamil, I'll just tell it in Tamil because it is very common in Tamil. நான் என்னைக்காச்சும் ஒரு நாள் சரக்கு அடிப்பேன், நான் ஃப்ரெஷர்ஸ் பார்ட்டி போறேன், அப்படி இல்லைன்னா பேச்சுலர் பார்ட்டி போறேன் மட்டும்தான் தண்ணி அடிப்பேன், இல்லைன்னா அடிக்க மாட்டேன். I'm not addicted towards alcohol or tobacco அப்படின்ட்டு you would have heard this statement, right? Many times. I will consume alcohol or I will smoke only during bachelor's party because of my peer group that I have. These are all some common statements that you would have heard. Why some people are very addicted to tobacco, some people they are not addicted to tobacco? Why is there a difference in addiction towards tobacco? Is because of this polymorphism by CYP2A6. Now in general, if you take CYP2A6 enzyme is concerned with metabolism of nicotine. You all know tobacco contains nicotine, right? So and the nicotine component is what is going to give us all the things. So if you take this CYP2A6 is going to be governed by 3 group of alleles. Okay, so if there is some change in the allelic expression of this enzyme, then addiction is not going to be expressed. So almost if you take in some individuals, we have this polymorphism by CYP2A6. So only one allele is going to be responsible for addiction, whereas other 2 alleles are not responsible. So CYP2A6 shows polymorphism. So one cytochrome P450, it's an important MCQ. So one important cytochrome P450 enzyme that shows polymorphism, it is CYP2A6. And inducible enzymes, you have given these examples. Very good. So this is about enzyme that is responsible for biotransformation. Okay, so I hope you are all clear. So heme containing enzyme, 150 isoenzymes, and then inducible enzyme to the third point, and polymorphism. That's it. Okay, very simple. Now we are moving on to biotransformation. Almost we are going to come towards the end of the session. Now you should know, get back to your 12th standard atmosphere where you are with your NCRT textbook or state board textbooks. Okay, mugging up all your organic reactions, right? So adhe mother will again get back to those amine chapters, toluene, aniline அப்படின்னா பார்ப்போம். So I hope no you all are good at chemistry. Okay, so if you have the chemistry knowledge, we are going to be thorough. Okay, biotransformation, if you take main, we have phase 1, phase 2, and there is also one more phase which has been included in certain textbooks, that is phase 3. Okay, but since it is not that common, I am not included here. But if your prescribed textbooks as phase 3, you can have a reading of phase 3 also. It will be like hardly 4 to 5 lines. Now I have told you, or a toxic substance is going to be converted into a non-toxic substance and be eliminated. Now, my next question is whether all toxic substances are simpler. Like, ஒரே அடியில நம்ம வந்து in Tamil we have this dialogue, right? வெட்டு ஒன்று துண்டு ரெண்டுன்னு அடிக்கணும். Whether all toxic substance at a single stretch be converted non-toxic? No. You need to have so many reactions taking place so to render it non-toxic. So most of the substances in our body can be made non-toxic at a single stretch. However, there are some toxic substances which has to be modulated, or which has to be modified twice or more than twice in order to render it non-toxic. So phase 1 abdina, the toxic substance is going to enter into one phase of reaction where it is going to undergo some changes. And the change, if it is going to render it non-toxic, it can directly be excreted. So, one level point it is going to escape. But first phase standium, if it is still toxic, our body will not leave that. It is going to take that and put it in the second phase. Okay, so where it is going to undergo some more changes. So phase 1 reactions and phase 2 reactions. So nama biotransformation. So whatever chemical reaction, as I told you in the definition, it is a chemical reaction that takes place in our body. So otherwise, when we have two phases. Phase 1 chemical reaction, phase 2 chemical reaction. Phase 1 chemical reaction, it is basically going to be addition of functional group. If you take, as I told you, imagine yourself as a 12th chemistry student. Oxidation, which means what? You're going to add some oxygen or remove some hydrogen. Hydroxylation, you're going to add water molecule. Reduction, addition of hydrogen or removal. Sorry, hydroxylation is addition of OH group. Sorry, hydroxylation is addition of OH group. Reduction, if you take addition of hydrogen or removal of oxygen. Hydrolysis, addition of water. Dealkalization, epoxidation, right? The epoxide group is added, and then dealkylation, you remove an alkyl group. Conjugation or Bina, you are going to add another substance to the metabolite. Like if you take, you would have studied, okay, I'll be explaining you conjugation, like bilirubin, unconjugated bilirubin to conjugated bilirubin, you would have studied all these, right? So you'll see what is conjugation. When an entire substance is going to be added, it is conjugation. When a functional group is added, it is called phase 1 reaction. The basic difference. So I hope you all know. First, we'll talk about oxidation. So oxidation, I hope you all know there's going to be addition of oxygen or removal of hydrogen and all that, right? So the first example, this again, I hope we all learned during our NEET times, right? Toluene. Okay, so I told you all the biotransformation reactions are going to be NADPH with an NADPH coenzyme. So there is addition of oxygen here. So what is going to happen in presence of the cytochrome P450 enzyme? This toluene is going to be converted to benzyl alcohol. So either biotransformation or question ketangna, define, mention what are the phases present and under each phase la what is happening. Phase 1 la or a functional group is being added. Phase 2 la conjugation. And each phase reaction, so you need to give some examples. So oxidation la, the first example is conversion of toluene to benzyl alcohol. Second is, now certain, I told you, right, there are some substances where we need to have two phases. So in the oxidation எடுத்தீங்கன்னா, it is mostly going to happen with the aromatic compounds. Like toluene if you take is an aromatic compound. But there are some exceptions for aromatic compounds also. Like benzene, if it is a xenobiotic, benzene is present. This benzene has to undergo two phases. First phase, addition of functional group. If you take OH is added and it will undergo conjugation, that is phase 2, where it is going to be converted to phenyl sulfate. So the toxic benzene is going to be converted to non-toxic phenyl sulfate, and this is going to be excreted in the urine. Okay, so this is how our body eliminates the toxic substances. So first is toluene benzyl alcohol. You can include this point also. So if you take benzene to phenol, it is an oxidation reaction, right? So you can just put a point, right? Certain aromatic compounds like benzene, it requires two phases for elimination. So phase 1 oxidation for the, and these are some examples. So the next question comes. Okay, my body is converting something to something. Does it mean that all the reactions will lead on to non-toxicity? No, absolutely no. We have some exceptions everywhere, right? A toxic substance which is less toxic can be rendered more toxic by means of some biotransformation reactions. Like if you take conversion of methanol to formic acid, methanol is less toxic compared to formic acid. So some biotransformation reactions can be leading on to more toxic substances. So these are some examples for oxidation. So toluene to benzyl alcohol, benzene to phenol, and these two reactions is going to render my xenobiotic more toxic. Methanol to formic acid, ethyl glycol to oxalic acid. Reduction reaction, so you all know addition of hydrogen or removal of oxygen. And main, if you take oxidation, I told you most of your aromatic hydrocarbons are going to undergo oxidation. Okay, and here if you take nitro compounds, be it aromatic or aliphatic, nitro compounds are especially going to undergo reduction reaction in the liver. So one example is conversion of nitrobenzene to aniline. Another example includes conversion of picric acid to picramic acid, paranitrophenol to para-aminophenol. So all these substances which undergoes phase 1 reduction reaction can be eliminated directly. So aniline is going to be less toxic, தூக்கி directா வெளில போடலாம். And all these substances can also be eliminated at a faster rate. Okay, I mean at the end of phase 1 itself. Next is hydrolysis. You all know hydrolysis if you take addition of water molecule. And this reaction again we have learnt in our organic chemistry 12th standard, if you remember. I guess the name of the chapter is aldehydes, ketones and carboxylic acid, right? So we all have learned there. So if you take, these are again some examples. So acetanilide, if you are going to hydrolyze, our body is going to hydrolyze this toxic substance to render aniline and then acetic acid. So if you see this, I need to teach chemistry now to you guys. So you all know this water molecule is going to contain hydroxyl group as well as hydrogen group, right? So what happens in case of hydrolysis is, or a single substance is going to be broken down into two fragments. Listen, or a single substance as a result of hydrolysis is broken down into two substances or two fragments. One fragment your OH is going to go and attach, and to another fragment a hydrogen atom goes and attaches. Observe this compound NHCH3CO. It is going to be broken down into two fragments. So cleavage will happen here. So we are going to have CH3CO and then benzene ring with NH. So this hydrogen goes to this fragment to become aniline. This OH goes to the acetate ion to become acetic acid. So this is what the hydrolysis nadakkudu. As a result, the compound is getting into two fragments. To one fragment, hydrogen is getting attached. To the other fragment, OH is getting attached. And I told you we take aspirin, which is a non-steroidal anti-inflammatory drug. Okay, so aspirin we take, and again if it undergoes hydrolysis in our body to render salicylic acid and then acetic acid. So the same story. Okay, so if you take, this is going, so the bond cleavage will take place here. So we are going to have O minus and then CH3CO will happen. So we will have OH attached here to form acetic acid, and in the O we are going to have hydrogen to form OH. Okay, ma, basic chemistry. Just I am giving you guys this piece of information to know understand a reaction, but simpler you can know simply memorize. Acetanilide, aniline and acetic acid are converted. The aspirin is getting converted to salicylic acid and then acetic acid. So all your organic chemistry equations. So I told you phase 1 reaction. So main oxidation, reduction, hydrolysis. That's what you need to include. Okay, so we will just now get on to phase 2 reactions. We'll just see some examples. So if you take phase 2 reaction, I told you conjugation reactions. So which means or a particular substance itself is going to come and get attached to this metabolite to render it non-toxic. So glucuronic acid acts as a conjugating agent. Sulfate acts as a conjugating agent. We saw this example already, like in oxidation, benzene, phenol, phenyl sulfate we saw, right? So that phenol is going to be conjugated with sulfate group to form phenyl sulfate and it is rendered non-toxic. Then conjugation with glutathione, you would have already studied in your carbohydrate metabolism. Acetylation, glycine, glutamine, all these you would have studied in your protein metabolism, right? So let's get some examples. Now this is a picture of e-metabolism. I'm not going into details. I just want to give you an example or make you guys remember. I just want to remind you guys on e-metabolism. So you have studied heme is going to be converted to biliverdin, that is in turn be converted to bilirubin, which is unconjugated. So it gets into the liver where it is going to acted upon by an enzyme called UDP glucuronyl transferase. And this bilirubin, unconjugated bilirubin, is going to be converted to conjugated bilirubin. Okay, so in the question exam like கேட்டாங்கன்னா conjugation reaction includes conjugation with glucuronic acid, sulfate, glutathione, acetylation, glycine, glutamine அப்படின்னு போட்டுட்டு you can know give some examples. Conversion of unconjugated bilirubin to conjugated bilirubin by means of UDP glucuronyl transferase. Okay, and even you can know, see there are some drugs also, but drugs it is given only in pharmacology. So I do not want to give examples of drugs. Okay, so we'll just go with biochemistry. Normal body endogenous substance that we are dealing. Okay, so this is about conjugation with glucuronic acid. Similarly, we need to understand some examples. So sulfate, I've already told you, benzene, phenol, phenyl sulfate. And if you take, this is one example of sulfate conjugation. This is an example with sulfate conjugation. Okay, so phenol plus PAPS. So PAPS is a substance that is present in the liver that is going to act as a sulfate donor. Okay, phosphate adenosyl. Okay, sulfate. I'm really sorry, I forgot the abbreviation. But if you take PAPS, is a sulfate donor. Like how we will have this methyl donor C1 carbon. So similarly, PAPS is a donor. Okay, so this phenol is going to act with this PAPS present in our body that is going to render phenyl sulfate. Okay, we saw that phase 2 reaction. Similarly, indole. Okay, so almost this phenolic and indolic compounds, they are going to undergo sulfation. Okay, and similarly, if you take, these are some examples of acetylation. So if you take, you have this N-acetyl transferase and you have this donor as acetyl-CoA. So where your isoniazid, which is a anti-tuberculous drug, it is being converted to acetylated isoniazid, and this drug is going to be excreted as a metabolite. Sulfanilamide is also another drug that is going to be excreted via urine by means of acetylation, acetyl sulfanilamide. And these are some examples. So this glycine glutamine I have already, I would have done with this transamination reactions if I am not wrong. Okay, so you would have studied, right? So if you take here some examples, benzoyl CoA or benzoic acid, it is going to be conjugated with glycine to render a non-toxic substance called ipuric acid. Similarly, if you take phenylacetic acid, is going to be conjugated with glutamine to form phenyl acetyl glutamine. Okay, so all these are some factual reactions that we need to memorize and write. So basically, what are the enzymes available? Okay, so acetylation na N-acetyl transferase, methylation na methyl transferase. Okay, and then glycine ka good example is benzoic acid, and glutamine ka we are going to have glutamate transferase enzymes and all that. Okay, so my primary objective of this session was just to give you an idea of how a toxic substance is getting into urine non-toxically. So we have some phase 1 biotransformation reactions that includes oxidation, reduction, hydrolysis. Phase 2 reactions that are conjugation, where an additional process has to take place to render it non-toxic. Okay, and these reactions, you are a very good chemist, So you can easily memorize just one or two examples. Okay, you can just write it down. Okay, so that you can get full marks in this question. So thank you all.